Y tenemos aquí el gusto y el honor de tener con nosotros a Steven Johns, que es miembro del estudio de Kieran&Timberlake, que para nosotros ha sido una referencia intelectual y práctica muy importante. Ellos tienen este libro, uy, no se va a ver bien, ahí se ve bien.
Sí, sí.
Refabricating Architecture es un libro que para nosotros fue paradigmático, o sea, realizó un cambio de paradigma en cómo entender la profesión. El mismo título de refabricar la arquitectura tiene que ver con el hecho de repensar los modos de hacer arquitectura utilizando las tecnologías de hoy en día. A mí sirvió mucho para mi tesis doctoral, ¿veis? Tiene muchas notas por todas partes. Y es un gusto tenerte aquí, también gracias a la intervención de Almudena, que pasó un año o dos en Filadelfia y también es una persona que conoce mucho el trabajo. Así que nada, voy a dar paso a Almudena, que va a hacer una presentación ya más completa de Steven y del estudio de Kieran&Timberlake. La charla de Steven va a ser en inglés, evidentemente, y para hacer que sea más fluida, lo más fluida posible, pues hemos decidido no hacer una traducción simultánea que podía complicar la conexión. Así que, bueno, para aquellos que su inglés no le permita seguir, bueno, haremos un pequeño resumen al final de la charla y luego pues entraremos en un debate y demás. Así que cuando quieras, Almudena, todo tuyo.
Perfecto. Okay, I am very happy today to have Steven here. Steven is an associate architect at Kieran&Timberlake and has been with the firm for 24 years. He's been part of the design and construction phases for several national awards, winning projects including Yale University's sculpture building completed in 2006, Brockman Hall for Physics at Rice University in 2008, the US Embassy in London in 2011, and Broome University College of Engineering in 2015. For us, the most important collaboration from our point of view here in this course, in INDUSTRIALÍZATE, is that he managed the design, fabrication, and installation of the cellophane house for the MoMA exhibition home delivery, fabricating the model dwelling, in 2008, which put into practice many of the ideas discussed in Refabricating Architecture, the book that Pablo showed us. And we are going to revisit this book today. Then I am presenting it. Are you seeing my screen?
Sí, it's green.
But
flat gray.
it's green.
Flat gray.
Oh, sorry. And now it's my fault. Now, it's okay?
Oh, yeah.
Okay. I am presenting this general slide to represent some of the major works he has been involved with in the studio, in the office. Steven shares his technical experience, knowledge of building system integration and construction techniques to advance Kieran&Timberlake's design, innovation, and documentation quality. He has and continues to be highly involved with Kieran&Timberlake's presence in the community to increase regional equality and diversity. He has lectured at Penn State University, where I have been there, Temple University, and Philadelphia University, being part of design juries at the University of Pennsylvania and City College of New York. I am very proud he has accepted our invitation to talk with us here in our course. Refabricating Architecture book and the Cellophane House were always part of our major references here and in our university. I am sure Steven's lecture is going to be very interesting. Thank you very much for coming, and you are very welcome, Steven. You have the audience, all for you. I give you the floor.
Okay.
Okay, I'm going to. Okay, sorry. Qué torpeza. que no.
Tienes que, sí, que
Yes,
dejar
I know, pero...
Yeah. ¿No puedes dejar de compartir?
Ay, no puedo, ya.
Ahora.
Dejar de compartir. Sorry,
Ahora.
sorry. So super sorry.
Okay, Steven, it's all to you.
Oh, now oh, there it is. I'm sorry. Welcome everyone from Philadelphia, home of Kieran&Timberlake, where we are an office of about 80 or 90 architects, designers, researchers, material scientists, and support staff. Our office is in what used to be one of the oldest breweries in Philadelphia. There is section in Philadelphia called Brewery Town. This office used to be the bottling plants for the Ortlieb's Brewing in Pennsylvania. It really became one of our first experiment in HVAC control. We spent a very hot summer or 2 summers where we didn't have any air conditioning. We had no conditioning in the space, thinking that we would get enough airflow in the hot, humid weather of Philadelphia in order to cool our environment. While that didn't pan out to be true, we did find a setting in air comfort control where it was much lower. I'm sorry, the set temperature for air conditioning was much higher than normal settings set forth by the American air conditioning standards. So that gives you an example into who we are. We suffered through a long hot summer, sweating during our office and during client meetings in order to kind of help us understand temperature control and how much heating or cooling we needed in a space. How do I advance? Here we go. A little lag. We are going to be talking in this family of buildings that we've done over the last several years since the publication of Refabricating Architecture. There's a lot of concepts and theories that go into these types of structures that we did between 2003 and 2008 that we'll get into much more detail later in the presentation. And again, Almudena mentioned, I've been at Kieran&Timberlake since 1996, worked on a number of university projects for Yale University, Rice University. We won a competition in 2011 for the United States Embassy in London that you see on the right, and a number of other buildings that are starting construction in the very near future, are in construction or starting in the recent past. So I don't know which slide to do. My daughter and I tried to translate. I think I can use this slide to describe our agenda for today. I want to talk about the origins and or principles of what started refabricating architecture, how it got started, how the ideas came to be, strategies as part of that, of refabricating architecture. We use our buildings as experiments and as artifacts, as I mentioned earlier. Buildings, during the experiment and artifacts, we'll talk quite a bit about the different processes that went into building them that were directly related to the theories in refabricating architecture. And then the last part, I'm going to talk a little bit about what's affecting our profession now. I'm not sure I have many answers for you and how to maintain the momentum of refabricating architecture, because it's a very difficult time. And I would really appreciate any commentary, insights, suggestions from you in order to further that discussion. So refabricating architecture came about because of a submission requested by the American Institute of Architect Fellows. They wanted to develop a research research endowment that would talk about not just the form of architecture, but the theories of architectures. At the time, we were talking quite a bit about what Steven James liked to refer to as self-referential, meaning we like to talk about other architects and what other architects were doing. They made the bold step to think about what it was that other industries were doing to make construction and fabrication more efficient. Kieran's father was an auto salesman. James Timberlake read a car magazine since he was a young child in the 1960s. And I think just intuitively looking at the industry, they realized that car manufacturers, airplane manufacturers were doing a much better job of building a quality product in a shorter amount of time with less cost. Now for myself on the right-hand side, my father renovated old race cars. So that's his race car there in yellow, and my garage in our suburban home in Detroit, Michigan looked very much like the picture on the bottom right. So I think we all had the same affinity toward how are things made and how are things made to be beautiful and durable. They identified as part of these manufacturers that they looked at as being building better quality products at lower cost with comfort and durability. And they looked at these three industries, and they realized that each of these things had a number of things in common. They all had to be durable. They all had to contain space that was comfortable and user-friendly for people. They also had to keep out air and water. So they thought if these manufacturing companies could do it, why couldn't we? Why couldn't architecture? So in Refabricating Architecture, they had this quote, which says that other manufacturers and other products are increasing their quality at a shorter amount of time for less cost. And they really thought that architects should start to act and take a lesson from these manufacturing companies. Now, again, this was in a time when the theory of architecture was much about what did Louis Kahn do? What did Corbeau do? We were looking at forms and shapes and theories. And this was in 2004, this was a very bold step to look outside of our own architecture. In 2006 and 7, Steve Kieran bought some property on the eastern shore of Maryland near Washington, D.C. And he put the same series of refabricating architecture into his own home. And as part of a book called The Loblolly House, Elements of a New Architecture, he stated the same thing, only with more economic, with more input about the economics of where we were, in that these people were producing much better products. The quality and the value of the products were increasing at exponential rates. While you can see on the bottom line, the bottom red line, construction was lagging in every category. It drove down the overall curve by being so poor. And they thought that this had to be an evolutionary change. And again, this is a kind of on the left-hand side, this formula is pretty common economic formula that even young students learn about. That the amount of time and the amount of cost that you put into a product should yield a certain amount of scope and a certain amount of quality. What Steven James realized was that Toyota and Boeing, they were having much more quality in their work. They were able to increase the scope for the same amount of cost and time. And they wanted to know why. So they went back a little bit and kind of looked at the history of what we've done, what other people have done, and how potentially to move forward, where the problems were in our thinking, and how could we improve that history. So he identified, and the word commodity for to be a little more clear about that, is products or things, objects that can be bought and sold. Property can be bought and sold, buildings can be bought and sold, cars can be bought and sold. So the term commodity has always been something that we've looked down upon in terms of it being just something that we can throw away. But I think they began to realize that a lot from what Corbu taught us, that in the fabrication of building the thing, it itself is an art. That the age that we live in, the tools that we use to build our commodities or or the things that we use every day can in themselves be a gateway to art. So this is, 3 pages from Refabricating Architecture, and it in a way kind of goes through a history of our thinking, and they ended in a point where they felt that the architecture that we are being left out of the means and methods of construction and fabrication, that the products and the machines have taken over really the formation of the form and the product, and we're just there simply to add pretty colors and knickknacks, as we say in the United States, kind of things that make it look fancy. Now, a real point, I think, I have a few ideas about some of the solutions about where we are today, and one of them includes a term that the AIA contract describes as means and methods. And I think even in our own firm, we have a confusion about what means and methods mean. In red, you see the definition laid out in the standard AIA form of contract for construction, produced by the AIA, that is the basis for all construction in the United States. The term means and methods means that when you get to a job site and the building is starting to get built, all of the means and methods of construction, how you build the building, is the full responsibility of the contractor. So we've interpreted that to mean that we cannot really describe how things are built, where to get the products, how to put the products together, how to assemble the products, and how to get those products to the job site. But I think a rereading of this section of the AIA contract in the bottom sentence of this suggests that we can define those methods, techniques, sequences, and procedures, but it's the contractor who's required to either say that that works or that doesn't work. And I think what we've, at least in the United States, what we've tended to do is we've forgotten about that second sentence and only adhered to the first sentence and let the means and methods of construction be solely guided by the architect, which I feel is really contrary to the idea of refabricating architecture. That was a brief aside. We'll get into that a little bit later, and I would very much welcome your opinions on that, because I don't think even Stephen James might agree with me. But going back to the origins of this, of refabricating architecture, they noted that the way we set up our contract methodologies is that it's a very straight line, it's a very ordered path. These are 3 what we call delivery methods. How do we design, bid, and then build a project for the owner? And these are ways that look very, very orderly, that the owner has responsibility and directs the contractor, the CM, and that owner directs the architects and engineers, and then the contract manager formulates the bids and hires subcontractors to get the building built. Now, Stephen, that in refabricating architecture, they say that this whole idea of this very orderly structure, as I'm probably sure anyone who's been practicing for a number of years would realize, that this process isn't true, that it's real chaos. Let me go back. That this kind of orderly structure is really it is not orderly at all. There's tangents, there's things that don't line up correctly, and it's pretty chaotic when in the end. to get a building to be built. Now, in 2004, the final theme, the final origin of refabricating architecture was the burgeoning, the real nascent 3D modeling tools that were at our disposal. Revit had just started, I think, in 2004 or 5. Revit had just begun to become the software of choice for architects. Frank Gehry was using these tools, CATIA, in order to find his shapes. And they began to think that these building integrated modeling tools could really help us recenter ourselves as being the lead in the means and methods of construction, all the way from design to fabrication and building. So they suggested that these new tools that we had available to us really allows us to gather much more information than we used to, and put that all into the workflow of who we contact, who we address, and integrate that into a single component or into a single artifact, a single built element. And at the time, they were thinking that that could be an IT software developer. And as fate would have it, Stephen, they were very forward thinking, because in the end, a company called CATIA followed this model. CATIA was formed in 2015 and really very much followed by an IT developer. And that IT developer started vertically integrating construction trades, design, and material scientists into a single entity, where the software was the organizer of the design. But then they also said in refabricating architecture, why can't that be architects? We have the tools available. Revit is coming online. It's only going to improve our modeling capability and building information capability. Why can't that central focus be us? Then going back and looking at what they were, looking at Toyota and Boeing, they started to break down these things as components. They realized that shipbuilders like Werner and Toyota were building all of these things off-site. They called them chunks or modules or cartridges. All of those were built by different companies, brought to a single site, and only when needed were they brought to the final assembly plant and put together as a single element. This quilting effect, again, increased the quality, reduced the time necessary to fabricate these elements, and increased what could be put into these components. So now I'm going to get into some of the work that we did starting in 2003, going all the way up to the cellophane house that Almudena mentioned earlier in the presentation. So even when refabricating architecture was being written, we had a project at Duke University. They had these very elegant doors that needed to include light fixtures, security controls, windows, lights, steel, wood, much like a car door. Why couldn't these things be built as a single component?
Stephen, sorry.
Yes.
Stephen, there is a pop-up window at the right down corner. Yeah. Sorry. Okay, thank you.
These are my messages from the office. I'm sorry.
Thank you. Thank you. Excuse me.
It's okay. So these doors, this door assembly was fabricated off-site. All the hardware brought to a contractor's site, fabricated as a single cartridge, and then dropped into a brick wall. 2003 was very busy for us at Yale University. Rather than build traditional architecture as they normally would, kind of using, bricks and steel studs and all the different parts and pieces brought to the site and laid down on a site, and then built, piece by piece. We contacted a off-site fabricator and built this project in a small area behind one of the colleges at Yale University. Refabricating architecture talks a lot about mass customization. So they began looking at different products and materials. I'm going to take a step back. They started talking about mass customization and ways to support elements of facades as a scaffold that could be changed over time. So this was a project for the Cooper Hewitt Museum in New York City. It was called a solo show. And they were allowing architects and designers to experiment with different ways of construction processes. This is a product that Steven James have copywritten. It's called Smart Wrap. And the intent of this was that hopefully someday all of our walls can control environmental controls by just a single layer of printed film. With different technologies, you could change the color of your facade, you could change the shape of your facade, you could control heat and weather on a single layer of film. Now this is Steve Kieran's house on the Eastern Shore in Maryland. It is a project that really started to develop strategies for how to put the ideas of refabricating architecture into practice. How do you get off-site fabricated, mass customizable fabricated pieces of construction to a very unique site? So they talked a lot about what would fit on the side of a piece that would fit on a truck. The scaffolding that you see here made of commodity products that anyone can buy off the shelf. Chunks, this bathroom chunk or utility room chunk that comes with all of its services and fittings already installed into it, onto a truck, dropped onto the scaffolding at the job site. All of this, again, off-site fabricated. And then cartridges. How could a cartridge, a floor cartridge that has a series of infrastructures, be that electrical conduit or heating pipes or security wiring, how could all of that be fabricated and connected at the job site as a single unit? Again, all off-site fabricated and brought to the job site with a truck. And again, these are the series used quite a bit by Toyotas and Boeings and Kverner shipbuilders. So soon thereafter, 2006, I believe, the Museum of Modern Art asked for submissions for an exhibition that they were going to have at a vacant lot next to the Museum of Modern Art. This kind of followed a long tradition of the Museum of Modern Art building unique housing types and housing prototypes in the garden of the Museum of Modern Art. Marcel Breuer did it, and there's been there's Philadelphia's own Japanese garden house now in Fairmount Park was built in the Museum of Modern Art's sculpture garden. I'll go through a series of images about how we came to this shape, how we came to this form, how we came to these means and methods of construction of a project that needed to be put up in less than a week and then disassembled and stored somewhere else after the 3-month exhibition was over. And again, this talked a lot about what we did with Steve Kieran's house. The chunks that were built off-site, the cartridges that ended up being platforms for those chunks, a staircase that was brought with a larger chunk, assembled and built off-site and then brought to the job site in a truck already fully loaded and ready to be dropped into place. And then a scaffolding that gets kind of not welded, but weaved together, much like a quilt. If you think about a quilt and different pieces and different parts of the puzzle working together to find a true unified crafted whole is what refabricating architecture was talking about. So I'm going to run through the process of, and I think this brings up a number of strategies that refabricating architecture talks about, but in 2008 we really put it into practice with the cellophane house. So here we have kind of the rendering sketches that were provided as part of the proposal. How could you build a house about 2,400 square feet that could be placed anywhere on different sites, hauled in by truck and dropped into place. So once we got to the design aspects of it, how do you start fragmenting the pieces? How do you start putting them into different size modules or different size chunks, as we like to call them? How do we start breaking all of those pieces apart? You know, going from a typical assembly down to a wall assembly, and then how do all those pieces fit together? So yeah, Steve Kieran talks a lot about, in his Loblolly house, quite a bit about the crafting of the joint. But this was kind of an experiment in understanding where the joints were, how to make those joints both economical and easily put together, but also to make them really beautiful. So we started taking the project apart and thinking about how to bring the different pieces together. Again, something we probably could not have done without the building information modeling tools that we had available at the time. We started looking at different materials that could be used, how they could be connected. Each of these pieces of frames that were made of essentially two tabletops, a rear tabletop and a front tabletop, and then a floor cartridge in between. So essentially, it's a series of stacked tabletops that are connected by a bridge. There's a large discussion in refabricating architecture about different tiers. Who do we contact in order to bring all of these elements together so that it can be a quick snap-in-place assembly in the job site? They talk quite a bit about tier 2 suppliers, or they talk about tier 1 suppliers. Somewhere between, they talk about tier 1.5 suppliers, where some of the material suppliers send their products to a 1.5 fabricator that then is given to a tier 1 supplier, and those tier 1 suppliers then feed that to a fabricator that can fabricate it in their shop and then disassemble it in order for it to be delivered to the job site. So in order to do that, how would you do that? How can you unstack and stack and take all these elements apart without damaging any of the material? Typical way of doing that is to, sandwich panels together with adhesives. We do that a lot at roofs. We do that a lot with our floor, with sealant joints. We do that a lot with air and vapor barriers, and we hammer and screw and nail things together, which essentially start to destroy the products. If you think about trying to reuse this floor plate, you would have to really rip apart it with quite a bit of effort and struggle. Cellophane House suggests that everything is simply hung, not damaged, not glued, no sealant, nothing of the kind, so that all of these products can be re-entered into the waste stream or be reused at a later date. I think early on, but really kind of in the end of this story, once we developed the form and the way to put the product or put the chunks together, we started to think about what was the best materials for that, for those means and methods of construction. How do we put these things together? What products can we use? in order that can be put back into the waste stream or be recycled for future use. So I'm going to just maybe quickly go through some of the slides about how this actually happened, rather, photographs of the construction process or the assembly process rather than diagrams. So here again, you see all of the tabletop surfaces being fabricated. Light fixtures are being installed. Floor panels are being installed. Lifting lugs, all of the different framework that we need to receive the floor cartridges are being in place. Everything that we need to drop this unit into place and be ready for the next unit to come within the next hour on the job site. The floor plates are being fabricated somewhere else in this large facility. Cranes allow us to kind of easily move back and forth between different chunks to work on different parts of the project. This craft of the joint became very important to us. How do we weave, or how do we, I'm sorry, the word weave is really important. It's a term that we don't want to use. Weaving means that there's kind of a deconstruction in the end. There's a demolition to the sweater. Say if you're weaving a sweater, all of those strands come together and are woven together in a full article of clothing. The term that I think I've referred to in the past is quilting. That there are pieces of fabric that are taken from, recycled from many different other places and sewn together, and that those sewing together creates the quilt, but then can be undone just as easily as it was fabricated. So again, this is a joint at one of the connections between the tabletop and the floor plate. And again, these intersections was well thought out. I think that if we have done it again, I think we would rethink it again to make it even easier. But that's part of the provocation that we had as part of the project. This is that stair that you saw being hoisted onto the job site, hoisted into place on the job site. Again, it was fully included as part of one of the tabletop chunks. It was fabricated again by what we call a tier 1.5 supplier. This supplier basically was a plastic manufacturer, so they provided the plastic and they had the tools in order to CNC mill all of the structural elements that were evaluated for structure to support our stairs. And then it was dropped into the chunk, and then this whole assembly that you see on the right was covered up and sent down the Pennsylvania Turnpike to New York City. Here's that bathroom, again by what we probably call a 1.5 tier supplier. This manufacturer was able to send these wall panels and all of the bathroom utilities to the fabricator. The fabricator put them together, dropped it onto our floor plate, and then hoisted into place on the job site. This, I think, is pretty self-explanatory. This is one of the tabletop chunks sitting on 54th Street outside of MoMA's entry. And this was the job site. MoMA, the Museum of Modern Art, is just to your left in this right-hand slide. I'll let this video run. This took about a week for all of these elements to be dropped into place. And then maybe another week to add some of the exterior wall assemblies and canopies. Should I run that again maybe one more time? for me, it was a very unique experience to be there, to be both a designer, fabricator, and installer. I was there the entire time, and again, I think we may have changed some of the connections at a later time, but really it was pretty flawless in its installation, and it's still moving even when I see it now. These are just some of the photographs that you can see in a book called The Cellophane House. Again, these joining of pieces, I think, is where we really think the craft is. You know, these elements need to do what they need to do in order to be driven or shipped from different locations. But it's this joining and the crafting of these things together that the BIM information modeling tools can really help us with, and can really push design and the speeding up and the fabrication of our projects, both to fit the client's needs and to really push the envelope of design. Unfortunately, both of these buildings are now gone. The Billy Chen Todd Williams project for the Folk Art Museum has since been demolished, and this project was taken by Jean. The site here is now a Jean Nouvel project. The story about the Cellophane House was we had a hotel that looked over Lehman Brothers, and near the end of the construction of Cellophane House, I looked down into some of their conference rooms with many middle managers very worried about I was looking into their conference room, and there were many worried looks on the faces of some of the middle managers. And during the exhibition is when the 2008 financial crisis hit. I think there was a real momentum for the ideas of refabricating architecture and for prefabrication in general, but that all came to a dead stop with the 2008 crisis. We talked long in the office about how best to disassemble the project. We thought for a long time that we'd maintain the chunks as they were, because we thought we might have a buyer for the project. That ended up not being true because of the financial crisis, and so many of the products that can be recycled were stored in a truck in New Jersey for a number of years before they were moved into our office. Now this is, I'm going to go into some of the issues that we've talked a lot about, how refabricating architecture developed, how some of the strategies were put into place for ways to make those concepts work so that we get a better quality product in less amount of time. And talk now about what has happened in the 18 years between Cellophane House, between refabricating architecture and the Cellophane House. As I mentioned earlier, the Cellophane House now sits disassembled in our office, ready to be reborn. All of these products, even at the beginning of the design of Cellophane House, we started looking at, what could be recycled, what's the best products to use from a structural standpoint for disassembly and sustainability. We didn't, in the writing of refabricating architecture, the main goal was not to think about sustainability. It was to increase the quality and productivity of our profession in a building. But in 2003, Cradle to Cradle was published. So these books happened within a year of each other. And while we didn't really address the sustainability issue in refabricating architecture, a number of the ideas of disassembly and not destroying the products and recycling those products and reusing those products to put them back into this cradle to cradle scenario was really kind of an offshoot of refabricating architecture. But because the economy was so bad, we really dove in hard into understanding our impact on the world. Soon after 2010, after the Sullivan House, and after we were kind of working through the economic downturn, we really focused on understanding our footprint, our carbon footprint in the world. Kieran&Timberlake developed a product which is now a Revit plugin called Tally that allows us to very quickly evaluate the impact that we have for the different materials that we're using. We've moved very adamantly into understanding even the simplest of assemblies, which ones have the highest impact on the global environment and sustainability issues. So we spent a lot of time since 2008 really kind of diving into material understanding. Because as James says, this kind of equality, this equilibrium discussion is really is in turmoil. We have an economy now that's growing at about 2%, but the cost of materials and labor have skyrocketed. So this cost number is so much more expensive that we're now finding all of our projects are about $20 million over budget. Our fees are being cut, costs are rising, labor forces are very, very small. You can't find labor, and when you do, it's very, very expensive. So this equilibrium has really been thrown out of whack. In 2008, actually even earlier, around the beginning of refabricating architecture in 2004, there was this new idea about how to deliver a project where this kind of simple stream of owner, I'm sorry, I didn't do this one, owner, construction manager, architect, this kind of linear distribution of labor wasn't working. And we started looking at this integrated project delivery, where the owner, the construction manager, the architect, and all the different trades were all in the same room, all together, designing together so that costs, quality, performance were all discussed at the same meeting. There was never any kind of separation between the different stems of this branch. But as you all know, we're in the middle of COVID and the 2020 sharp decline in the economy. And what we're seeing now is that this whole idea, because it didn't necessarily pan out, it didn't quickly save the client much money, that we've stepped back and really the owners have essentially kept us in this because it's a tried and true method. And it's this kind of linear process that I think refabricating architecture was really trying to discard and really come up with a model where everybody was integrated under a single platform. Now in 2015, Katerra used this, I think I mentioned this earlier, that Katerra had used this model in order to develop a linear, a vertical supply stream where they had designers or building material scientists and industry and product engineers working in Toronto. They had architects and different construction trades in the United States. They had other fabrication facilities in Asia and in Europe. And it was all tied together with an IT software. Mr. Marks, I'm sorry, let me find his name. He was an IT developer that had started an IT company called I'm sorry, let me find my notes. Michael Marks. He was developer of a company called Flextronics, which was a supply chain product that was able to kind of streamline supply chains. And so he used that same software in the construction industry. Unfortunately, the economy is not fair to us, and they are now being restructured. James just last year mentioned that they might be expanding too large, and they're kind of financed by a venture capitalist company, and so they really don't have to make a profit at this point. And this whole organization will be interesting to watch over the next few years once we get out of the pandemic and back to normal. So I was mentioning to Pablo earlier in the meeting that we had an interview with Steven James about a year ago before COVID happened, and we talked a lot about what's happening now and what's causing the ideas of refabricating architecture not to be really why a client mandate hasn't really asked us to move forward on these ideas. And I think they mentioned that we may be our own worst enemy. The AIA contract tries to alleviate us of any liability. So we're kind of locked into those restrictions that don't allow us to share the liability with contractors and owners. Something that IDP tried to address. But again, there is no real client mandate for that. Of course, we have the economic downturns. We had 4 years of a very unsure political mandate from states or the federal government. We'll see how that plays out in the next 4 years. Steven James talked a lot about master spec, which is what we use as our basis for specification writing. When they were in practice as young architects, there were, I think, 16 divisions. Now it's expanded to 32. And there are basically 480 sections that we had to deal with. That kind of specialization is really hurting the idea of integrating assemblies and products into a single chunk that can be used as part of the construction industry. And then, of course, we've got, labor unions, mechanics, OSHA, that all have a say in revolutionizing the construction industry. They're not going to want to move very much, and so they are always something that we have to think about as well. This is, in a way, kind of my premise. I think that I talked a lot about means and methods of construction, and I think that while some of those things that drag the construction industry down could also be our partners. I think that if we try to talk to labor unions and OSHA and some of the industry standards that we have in the United States or in Europe, we could basically let them know that working in an on-site facility is safer for everyone, safer and better quality. Uniformat is a way of classifying building assemblies, much like master spec, only it does it in 7 or 8 sections rather than the 32 that master spec does. And personally, I think this, well, let me preface this by saying that this is some mock-ups and tested components for the United States Embassy. You might recognize this shape as being on the embassy. Kieran&Timberlake is doing a lot of mock-ups in our own shop. We have our own shop where we mock things up life size, full scale, with as much of the same product as we can. But being, I think, more involved in those means and methods of construction and in the actual testing process in order to convince clients that our unique and innovative solutions are appropriate might require us to take on the monetary need to test our products, test our assemblies, let them go through some of the test standards that are usually left to the client. So again, I think I might end here again by this thesis, that I think if there's a way that we can take on more of the process and the means and methods of construction, I think that might be one way. Now, granted, I'm not the owner of Kieran&Timberlake and Associates, so I don't have much liability or much money in the game. So I can say this quite easily, but I think if we were able to really understand the processes of construction, how things are fabricated, how they're built, how they're assembled, and how we can make it easier to assemble on the job site, I think it would go some way into making this dream model, I think, a reality. But again, we have to get out of the economic downturns and the uncertainties of our own culture, and that will take some time for us to work through. Thank you. Again, I don't have this. I think it ended with a more of a question and more of a premise that I'm not completely sure about. But I welcome any conversation, any comments, anything you want me to go back to in the slide presentation. I can stay for as long as you need, or for the next hour, depending on how long.
Perfecto. Okay, Steven. So thank you very much. Thank you so much for the presentation.